Hello, welcome back. Today we're going to be solving quadratic equations using the quadratic formula. The objective is that by the end of this video, you should be able to solve an equation that looks like this using, again, something called the quadratic formula. To get us started, we've got some vocabulary, the first of which is a solution to an equation. And a solution to an equation is a value or values that can be substituted in for the variables in an equation to make the equation true. For example, we're going to take a look and see if 3 is a solution to x squared minus 3x. So, based on our definition, if we substitute 3 in for x squared and for the x, it should give us a true statement if it's a solution. So let's try that. 3 squared minus 3 times 3 equal to 0. 3 squared is 9, minus 3 times 3 is 9. 9 minus 9 is 0, 0 does equal 0, so the answer is yes, 3 is a solution to the equation because when substituted in for the x values, it makes the equation true. We're also going to take a look at what the quadratic formula actually is. Quadratic formula is this big long thing right here. X is equal to the opposite sign of b plus or minus the square root of b squared minus 4ac all over. The entire thing is over 2 times a. A, b, and c come from the standard form of the quadratic equation, ax squared plus bx plus c equals 0. And the most important part, the whole point of this video, is that the quadratic formula gives us solutions to quadratic equations. So we'll be able to solve any quadratic equation we're given just by finding the a, the b, and the c value, and then substituting it into this formula right here. So we've got some steps here how to solve a quadratic equation using the quadratic formula. First thing we've got to do is we've got to get it in standard form because that's going to allow us to find the a, b, and c values. Once we know the a, b, and c values, we're going to substitute those values in for a, b, and c into the quadratic formula. Then we're going to simplify, and that will be our solution. So to get us started, we've got an equation right here that we're going to solve using the quadratic formula. Note that the quadratic formula only works on quadratic equations, meaning your largest exponent is a 2. So the first thing we're going to do is we're going to try to get our equation equal to 0, and to do that, I'm going to take away 5 and take away 3x from both sides. This gives me, I always start with my largest exponent first. So I'm going to start with that 7x squared and write that down first. Then I'm going to move to my x terms and see if I have any like terms there. Notice I have an x and a negative 3x. So I'm going to combine those to give myself negative 2x. Then my constant is negative 5, so I write down negative 5. Now on the right hand side of the equation we have 5 minus 5, which is 0, 3x minus 3x, which is 0, so it gives us 0 on the right hand side. Now that I have the equation in standard form, ax squared plus bx plus c equal to 0, I need to identify my a, my b, and my c values. The a is the coefficient of x squared, so a is going to be equal to 7. The b is the coefficient of our x term, so it's negative 2. And the c is the constant, which in this case is negative 5. Now that we know what a, b, and c are, we're going to take a, b, and c and we're going to substitute them into the quadratic formula and then simplify to solve. So I've got the quadratic formula here, and I'm going to substitute in first just so you can see that step, and then we're going to go ahead and simplify as much as possible. So the quadratic formula is x is equal to the opposite sign of b, so it's negative, and my b value is negative 2, minus the square root of, plus minus b squared, so our b again is negative 2, minus 4 times our a value is 7, times our c value, which is negative 5, all over 2 times the a value, which happens to be 7. Now that we have substituted in the a, b, and c values into the quadratic formula, we're going to simplify and evaluate it using PEMDAS as much as possible. I went ahead and rewrote what we've done so far so we can move on to the next step. Now our next step again is just to simplify. So I've got x is equal to, and again we're just going to simplify what we can, going from left to right and doing the inside of the square root as much as possible. So we get negative negative 2, and we just switch the sign of 2, so it gives us a positive 2 plus or minus the square root of, let's separate that top and bottom, negative 2 squared, that's positive 4, minus 4 times 7 times negative 5 is going to give us a positive 140, all over 2 times 7, which is 14. So x is going to be equal to 2 plus or minus the square root of 144 over 14. Now the square root of 144 is 12, so we get x is equal to 2 plus or minus 12 over 14. Now that plus and minus sign means that there are two solutions possible, one positive and one negative. So when we're simplifying our answer, we have to split it up into the two possibilities. Let me show you. We have to write x is equal to 2 plus 12 over 14, and we have to write x is equal to 2 minus 12 over 14. So 2 plus 12 is 14 over 14, which means x is equal to 1 is one of our solutions. The other thing we've got is x is equal to 2 minus 12, which is negative 10 over 14. When reduced, gives us x is equal to negative 5 over 7. X is equal to 1 and x is equal to negative 5 over 7 should be the solutions to our quadratic equation, which we could check by substituting back into the original equation and seeing that the left-hand side and right-hand side of the equation were equal. For additional practice, please work the 3 following problems. As you're working through them, you will notice that the second and third problem work out slightly differently than the first problem listed. So please work through all 3, pressing pause, working them out, and pressing play when you're ready to see the answers. I went ahead and got the equation equal to 0 and wrote it in standard form. Found a equal to b, or rather 3, b equal to 12, and c equal to 12. Substituting those values in, I simplified the inside of the square root, got 144 minus 144, which gave me 0 inside the square root. So, when I simplify that a little further, I get negative 12 plus or minus the square root of 0. Now the square root of 0 is just 0 over 6. So, in the end, I get x is equal to negative 2 as my one and only solution. For the second example, I got a equal to 1, b equal to negative 9, and c equal to negative 11. When I substitute those values back into the equation, I got 9, x is equal to 9 plus or minus the square root of 125 over 2. Now since the square root of 125 is not a perfect square, meaning it does not have a whole number square root, we're just going to write our final answer as 9 is equal to, or x is equal to 9 plus or minus the square root of 125 all over 2. For the third example, I got a equal to 2, b equal to 6, and c equal to 6. When I substitute that in for the quadratic formula, I got negative 6 plus or minus the square root of 36 minus 48 over 4, which gave me negative 6 plus or minus the square root of negative 12 over 4. And what I want you to point your attention to for this problem is that you have a negative number inside of your square root. Now we do not yet know how to take the square root of a negative number. So anytime you see this situation happen, I want you to write no real solution. Meaning there is no number that we can substitute into our original equation, no real number that is, to make the equation true. And the reason we know that again is because we ended up with a negative number inside of our square root.